Imagine a computer program that can understand and generate human-like language, helping us with tasks from writing emails to solving complex problems. DeepSeek-V3 is just like that, a cutting-edge language model that is changing the game with its incredible abilities and efficiencies. With its massive 671 billion parameters, it is one of the most advanced AI models out there, capable of processing vast amount of data and learning from it. In this video, we'll dive into the world of DeepSeek-V3, explaining its innovative architecture, training process, and capabilities in simple, easy-to-understand terms. So whether you are an AI enthusiast or just curious about the latest tech trends, get ready to uncover the power and potential of DeepSeek-V3. So let's get started with understanding what is DeepSeek-V3. Basically, it is a large language model developed by the DeepSeek AI team. It is a significant improvement over its predecessor DeepSeek-V2 and has achieved state-of-art performance on various benchmarks. DeepSeek-V3 is based on transformer architecture, which is a type of neural network designed for natural language processing tasks. Here, the model consists of multiple layers, each comprising two main components: multiple head latent attention and DeepSeek MOE, which is a type of mixture of experts. First, multi-head latent attention is a modified version of traditional multi-head attention mechanisms. Basically, it reduces the memory requirements during inference by using a low-rank joint compression for attention keys and values. This allows the model to efficiently process long sequences of text. To illustrate this, imagine you are trying to find a specific book in a large library. Traditional attention mechanisms would require you to look at every book on every shelf, which would be time-consuming and memory-intensive. Whereas multi-head latent attention allows you to create a condensed index of the book, making it easier to find the one you are looking for. DeepSeek MOE is a type of mixture of experts architecture. It uses the combination of shared and routed experts to process different parts of input sequence. Here, shared experts are used for all tokens, while these routed experts are selected based on the input token's characteristic. So think of it like a team of experts working on a project. The shared experts are like the journalist who can handle any task, while the routed experts are like the specialists who are brought in to handle specific tasks. This allows the model to efficiently process the wide range of input sequences. DeepSeek-V3 introduces an auxiliary loss-free load balancing strategy, which helps you to distribute the workload evenly across the experts. And this is done by using a routing mechanism that selects the experts based on input tokens characteristic without adding any additional loss term to the model. To illustrate this, imagine you are managing a team of experts working on a project. You want to ensure that each expert is working on a task that is suitable for their skills without overloading or underloading any of them. The auxiliary loss-free load balancing strategy helps you to achieve this by dynamically assigning tasks to the expert based on their strength. Now, DeepSeek-V3 uses a multi-token prediction training objective, which involves predicting multiple tokens in a sequence simultaneously. This helps the model to learn longer range dependencies and improve its overall performance. For example, imagine you are trying to predict the next word in a sentence. So traditional models would predict one word at a time, while DeepSeek-V3 can predict multiple words simultaneously. This allows the model to capture more context and improve its accuracy. Now, DeepSeek-V3 was trained on massive dataset of 14.8 trillion tokens using the combination of supervised fine-tuning and reinforcement learning. The model was trained on a cluster of 2048 H800 GPUs, which allowed for efficient and scaling training. To put this into perspective, imagine you are trying to train a model on large data set of images. You would need a powerful computer with multiple GPUs to process the images quickly. DeepSeek-V3's training process is similar but on a much larger scale, with thousands of GPUs working together to train the model. Now, DeepSeek-V3 has achieved state-of-art performance on various benchmarks including MMLU Pro, GPQ and more. The model has also demonstrated impressive performance on code and maths-related tasks, outperforming other open source models. For example, imagine you are trying to solve a complex math problem. DeepSeek-V3 can generate step-by-step solution, making it a valuable tool for students and researchers. Similarly, the model can generate high-quality code, making it useful for software development and other applications. So let's see the paper which we have discussed till now. So let's see the paper. So this is the paper which we have discussed, DeepSeek-V3. So here we have discussed all its introduction first, and then we had discussed that it is using DeepSeek MOE and multi-head latent attention, and it also uses transformer blocks, and we have discussed that it uses the attention also. So that we have discussed, and then we have seen that it uses this cross entropy loss function. It has embedding layers, RMS, norm, and then we can see that it is using the MTP in inference, and then it is using the large number of GPUs. And then this is the whole paper which you can get from their sites. Then this is, they are using the quantization and other things, and finally they're using prefilling and other things. So you can get this paper like this way, which we have discussed in a simple terms, including only major facts there. And that's the wrap. DeepSeek-V3 is a powerful language model that has achieved state-of-art performance on various benchmarks. Its architecture, which includes MLA DeepSeek MOE on auxiliary loss-free load balancing, allows it to efficiently process long sequences of text and learn longer-range dependencies. This model's multi-token prediction training objective and massive dataset has also contributed to its impressive performance. Thank you.